Alas, we have the last page of your study guide video. This entire page is devoted to section 9.8. So if you struggle with anything on this page and you need to go rewatch that video, that's going to be on 9.8, which is De Moivre's theorem, or being able to raise polar complex numbers to a particular exponent. So this whole page, we're going to be making use of this equation here, r cosine theta plus I sine theta, all to the n power. So we'll be referencing that. In fact, let me just write that on the top of this page as I refer to it. Okay, so we're going to have r times cosine theta plus I sine theta, all of that raised to the n power. De Moivre's theorem says can be rewritten as r to the n power times the cosine of n times theta plus I times the sine of n times theta. I guess I didn't need these outside brackets, actually. Okay, so that n applies to it in those three places. All right, numbers 20 and 21, I give you kind of step one, if you will, or actually a couple steps. Your job is just to apply De Moivre's theorem. So if I look at the question that I'm given here, this 3 is r, this 3, the power is n, and then of course, pi over 6 is theta. So we are going to use the expansion on the right-hand side to expand number 20. So this is going to equal r to the n power is going to be 3 to the third power, open parentheses, times the cosine of n times theta. So I'm going to say, okay, pi over 6 is theta. N is going to be 3 times pi over 6 plus I times the sine of n times theta, which will be, again, 3 times pi over 6. And then we just need to simplify this. So 3 cubed is 27. Times the cosine of 3 times pi over 6 is the same thing as pi over 2. I don't really need coordinates or parentheses. So it's the cosine of pi over 2 plus I times the sine of, again, pi over 2. And then this is where the unit circle comes into play because I need exact values. So I'm going to have 27 times the cosine of pi over 2, the x value at pi over 2. That is a vertical line, so that x value is 0. Plus I times the sine at that point, the y value is 1. And then this 27 distributes to both of those. Well, 27 times 0 is just 0. And then 27 times I is 27i. And then that's our final answer. For number 21, same idea. R is 2, n is 5, and then theta is pi over 4. So we're going to use the De Moivre's theorem to expand this. It'll be 2 to the 5th power times the cosine of n times theta. So that's going to be 5 times pi over 4 plus I times the sine of n times theta, which is 5 times pi over 4. And then we just need to keep reducing. 2 to the 5th power is 32 times, this will be the cosine of 5 times pi over 4. It can't be simplified or anything, so it's literally just going to be 5 pi over 4 plus I times the sine of 5 pi over 4. So that's as much simplifying as we can do so far until we bring in the unit circle. So if we look at the unit circle, then we're going to have 32 times. Locate the angle, 5 pi over 4. And then the cosine is going to be the x-coordinates at that point, or at that angle, which will be negative square root of 2 over 2, plus I times the sine, the y value at that angle, is going to be negative square root of 2 over 2. And then this 32 is going to distribute to both of those terms. So then 32 times negative square root of 2 over 2 is going to be a negative. 32 divided by 2 is 16. And then we leave square root of 2 alone. Then the next number is also going to be negative. 32 divided by 2 is still 16, square roots of 2, and then remember we put I at the end. So to readdress the end of page 3, if you didn't watch that part, if I ask you for your answer in rectangular form, it's got to be A plus BI. So I need A, B, and I to be 3 distinct numbers in that order, which we have here. A is negative 16 square root of 2, B is negative 16 square root of 2, and then of course I is I. You don't want to write I mixed in with B at all. This is technically the simplest version of rectangular form. Okay, 22 through 25 look a little bit different. The question is still the same. I still want you to give me simplify this answer in rectangular complex coordinates, or in that form, except you have to do a little bit of work to get there. Notice 20 and 21 were pretty straightforward. I plug it into De Morph's theorem and I simplify and I'm done. For the rest, we need to first convert it into polar form. So in order to do that, I need to first find r and theta. So r is going to equal the square root of negative 2 squared plus 2 squared, which will be the square root of 4 plus 4, which is 8, which the square root of 8 could be rewritten as the square root of 4 times the square root of 2. Square root of 4 is 2 square roots of 2. So r is 2 square roots of 2. To find theta, we're going to do tangent inverse of y over x, which is 2 over negative 2. Now, since x is less than 0, that means we also need to add pi to this. So then this is going to be tangent inverse of negative 1 plus pi. Now, there are two answers that have inverse tangent of negative 1. The one that I want you to choose is the principal value of this, which we kind of breezed over this a few weeks ago and didn't talk about it as much as we should have, and that's okay. But going forward, when you're choosing, when you're looking at your unit circle and you say, okay, which angle has a tangent of negative 1, you're going to have two choices. Okay, your first choice is 7 pi over 4. The second choice is 3 pi over 4. But I actually want you to just treat this almost as, I'm going to write this off to the side here. Treat it as if it were positive. If I ask you what is tangent inverse of positive 1, you would probably choose the angle in quadrant 1, which is pi over 4. Well, since I'm asking you what is the inverse tangent of negative 1, that answer is actually going to be negative pi over 4, which is the same thing as 7 pi over 4. I just wrote it going clockwise around the unit circle instead. So it's negative pi over 4. Then, when I add pi, this is going to be, so negative pi over 4 plus pi. I'm going to go ahead and multiply this guy by 4 over 4. That way, when I add these two fractions together, negative 1/4 pi plus 4/4 pi will be a positive 3/4 pi, or 3 pi over 4 for theta. If you chose the other angle for theta, like maybe you wrote 7 pi over 4, you're going to end up getting the same answer as me. You would probably look like 11 pi over 4, but then later you're going to have to do some other simplification work. So it's easier if you choose the one that's in quadrant 1, and if it's negative, then just make your answer the negative of that. Okay, so as we proceed, now you can write this in polar form, just like number 20 and 21 were given to us. So I'm going to switch colors so that you know we're kind of writing it differently. So then, if I rewrite this rectangular form, I would do 2 square roots of 2 times the cosine of 3 pi over 4 plus I sine of 3 pi over 4. And all of that is raised to the third power. Okay, so all of that was to find this. And then once you find this, then you use De Morph's theorem just like we did for 20 and 21 to expand this. Okay, De Morph's theorem says we're going to raise 2 square roots of 2 to the third power. So 2 square roots of 2 cubed times the cosine of 3 times 3 pi over 4 plus I times the sine of 3 times 3 pi over 4. Now, 2 square roots of 2 cubed. If you have a hard time understanding that, literally expand it 3 times. 2 square roots of 2 times 2 square roots of 2 times 2 square roots of 2. And then we can simplify the cosine of 3 times 3 pi over 4 is just going to be 9 pi over 4 plus I times the sine of 9 pi over 4. And then when you multiply these numbers out front, 2 times 2 times 2 is 8, times the square root of 2 times the square root of 2 is another 2, and then 8 times 2 is 16 square roots of 2. Times, when you look at your unit circle, 9 pi over 4 is not on your unit circle, right? That's going around the unit circle and then doing another pi over 4. So this is the same thing as pi over 4. Okay, so when looking at that, the cosine, the x value at pi over 4 is the square root of 2 over 2. Plus I times the sine, the y value at that angle is also the square root of 2 over 2. And then when we distribute the 16 into both sides, we end up with, let me write it down here. Okay, so then we end up with, let's see, 16 divided by 2 is 8. And then the square root of 2 times the square root of 2 is just 2. Plus, similar on this one, 16 divided by 2 is 8. Square root of 2 times square root of 2 is 2. And then we have I at the end. So 8 times 2 is 16 plus 16I. Let's do another, number 23. Again, the first thing we got to do is find r and theta to convert this to polar form first. So r will equal the square root of 3 squared plus -1 squared. Well, the square root of 3 squared is just 3, and then -1 squared is 1. So that's going to be the square root of 4, which is 2. So r is 2. Theta is going to be tangent inverse of y over x, which will be -1 over the square root of 3. We don't have to add pi because our x value is positive. Since I want an exact value, this will be tangent inverse of. If I go ahead and rationalize this tangent here, multiply both sides by the square root of 3 over the square root of 3, then I end up with tangent inverse of negative square root of 3 over 3. And then again, if you look at your unit circle, on the unit circle, you should have filled out all of the tangents. And so in the first quadrant, if you look for the tangent inverse of positive square root of 3 over 3, you end up with theta being equal to pi over 6. Which means if you do the tangent inverse of negative square root of 3 over 3, then theta will equal a negative pi over 6. That's the easiest way to do it, is look for the positive in quadrant 1 and then just make that answer negative. So now that you have r and theta, we can convert this to polar form by writing 2 times the cosine of negative pi over 6 plus I times the sine of negative pi over 6. And all of that is raised to the third power as it is written in the question. And then we're going to use de Moivre's theorem to expand this and simplify it. Oh, I lost some ink somewhere. Oh well, you already saw number 12. Well, let me see if I can get it back. I don't want to go back too far. It might some erase more recent stuff. Okay. So de Moivre's theorem says we're going to raise this 2 to the third power times the cosine of n times theta, which will be 3 times negative pi over 6. Kind of looks like a double negative. Negative pi over 6 plus I times the sine of 3 times negative pi over 6. So 2 cubed is 8. Times, this will simplify to be the cosine of negative pi over 2 plus I times the sine of negative pi over 2. And then again, we're going to actually use the unit circle to figure out those values. So leave 8 alone. Cosine of negative pi over 2. Remember, negative pi over 2 is just going clockwise around your unit circle, which is going to be the same thing as 3 pi over 2. The x value at that point is 0, plus I times sine the y value there is down 1, so it's negative 1. And then you're going to distribute this 8 into both terms. Well, 8 times 0 is still 0. And then 8 times I times negative 1 will be negative 8I. Okay, for 24, this is the only exception, and I told y'all this in class. This one, I want you to go ahead and round. Okay, nearest hundredth where necessary. Okay, so same thing as we've done the last couple of problems. The first things we've got to do are find r and theta. So r is going to be the square root of 2 squared plus 4 squared, which will be the square root of, that's going to be 4 plus 16, which is 20. And the square root of 20 can be simplified to be the square root of 4 times the square root of 5, which will be 2 square roots of 5. So that's r. Theta will be found by doing tangent inverse of y over x, which is 4 over 2. We don't need to add theta because, add pi because x is greater than 0. So because you are allowed to round, that means you can type this into your calculator. Make sure you're in radian mode because that's our default. And then you should end up with theta is approximately 1.11. In polar form, we can rewrite the question as 2 square roots of 5 times the cosine of 1.11 plus I times the sine of 1.11. All of that raised to the 4th power. Lots of parentheses there. Using De Moivre's theorem, this is saying we can do 2 square roots of 5 to the 4th power times the cosine of 4 times 1.11 plus I times the sine of 4 times 1.11. And then we just got to keep on simplifying. Again, 2 square roots of 5 to the 4th power. If you struggle to see that, literally write it out 4 times. 2 square roots of 5 times 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 the cosine of 4 times 1.11 will be 4.44 plus I times the sine of 4.44. When we multiply all this stuff, we're going to get 2 times 2 times 2 times 2. So 2 times 2 is 4 times 4 is, that'll be 16. And then the square root of 5 times the square root of 5 is just 5. The square root of 5 times the square root of 5 is another 5. So you'll do 16 times 5 times 5 times the cosine of, well, actually, to save us from having to write this all out again, when you do 16 times 5 times 5, you should end up with 400. Okay, and then actually calculate, again, make sure you're in radian mode. The cosine of 4.44 will be negative 0.27 plus I times the sine of 4.44 will be negative 0.96. And then when you distribute 400 to each of those, you're going to end up with the approximation, because we rounded, of negative 108 minus 384i. Now, if you rounded at a different spot than me, like maybe you kept some things in the calculator longer, your numbers might be a little bit off. As long as you're clear in your work and showing me, what your calculator screen looks like, things like that, there's a chance that I will accept more than one answer, because the rounding ones can be a little bit tricky depending on when you actually round. Last question, number 25, we're back to giving an example, or giving your answer as an exact answer. So same start to the problem, we need to solve for r and theta. So r is going to equal the square root of 1 squared plus the square root of 3 squared. 1 squared is 1. The square root of 3 squared is just 3. So that's the square root of 4, which means r is just 2. To find theta, it'll be tangent inverse of y over x. So it'll be the square root of 3 over 1. We don't need to add pi because x is greater than 0. So then, if you look at your, square root of 3 over 1 is just the same thing as square root of 3. If you look at your unit circle, the value of theta, the angle that has a slope or a tangent of square root of 3 is pi over 3. And then if you use that r and theta, you're going to convert this to the polar form, which will be 2 times the cosine of pi over 3 plus I times the sine of pi over 3. All of that raised to, the question says, the 4th power. And then if we use de Moivre's theorem, we can go ahead and break this down, which would be 2 to the 4th power times the cosine of n times theta. So that'll be 4 times pi over 3 plus I times the sine of 4 times pi over 3. So again, in all of these guys, that 4, whatever that exponent is, will drop in 3 places. It'll raise r to that power, and then you multiply theta by that number. And then we keep on simplifying. 2 to the 4th power is 16 times the cosine of 4 pi over 3. We can't simplify that at all. Plus I times the sine of 4 pi over 3, which will equal 16 times the cosine of 4 pi over 3. So if you locate that on your unit circle, cosine is the x-coordinates at 4 pi over 3, which is negative 1/2. Plus I times the sine is the y-coordinates at 4 pi over 3, which is negative square root of 3 over 2. And then we're going to distribute this 16 into both numbers. So the first one, 16 times negative 1/2 is negative 8. 16 times negative square root of 3 over 2. So 16, well, again, it'll be negative. 16 divided by 2 is 8. Can't do anything with that square root of 3. And then we write I at the very end. And that wraps up all of your study guide tutorials. I hope it helps.